class. So I'll say it one more time. Look at the next couple days for today and or today and then Friday. There's only one obligation and only one obligation, no outside of class obligation. So that's good. And then that gives you a chance to catch up. But I've noticed a lot of people did not do the red puzzle, like up to 16 people. Now, I do understand I had you last hour yesterday that we meet. That needs to get better. So there is a lot of free time. What I've noticed is we have a lot of free time, a ton. I'm actually enjoying it. I'm able to figure out more stuff to do, not give you more busy work, but it's just there's a lot more time to get stuff done, and we need to actually use that time. I know you have other classes, I get it, but management of that is certainly going to be a thing. So tonight, that ed puzzle must be done, and then we can move on to any time for homework on this. Homework's real short. It's only 11 questions total, 2 different separate concepts. So just be aware of that, as we get going. But it is nice. There is only one obligation today, one obligation Friday. And then just as we move forward, yes, September 4th is going to be that chapter PR test. And I'll talk about that when I have certain things that we're going to have for notes today. Okay, time for attendance. I'm going to stop tape for the lesson. Okay, boom shakalaka. All right, you feel free to read all this. Remember, you have your note sheet. So go ahead and pull that note sheet out. You should always have that prepared and ready to go since we have it for this first chapter. Okay, all right, this is solving systems. I'm going to go ahead and blabber and actually do the first thing, kind of relate this to what are these? And what these are 2 lines. That's all they are. If you didn't watch that ed puzzle, naughty. But that's when lines are discussed, like equations of them. So for this first one, this is actually the first step for substitution. What you need to do for substitution is get one of the equations in terms of one of the variables. So I solved for y. Then, okay, before I do that, you better remember this, and I should not have to teach this. This is a line with a slope of 2 and a y-intercept of 4. Y-intercept of 4. So if I were to graph this, and by the way, you're not supposed to graph when you're doing your homework. Don't. Just showing you something. Rise 2, run 1. Here's the next point. Then we could do that forever. This is approximately what that line would look like in a coordinate plane. Now, I'm not going to solve for y. It's not the point of all this, but this line has a slope and a y-intercept, and let's pretend it does this, and it looks like this. Well, then the solution to the system is the point that they intersect at. So just make sure you understand that as we move forward. Okay, all right. Excuse me. Not COVID, just have a cough. All right. So let's go back to the solving through substitution. Step 1 is you solve one of the equations for one of the variables, then you substitute into the other equation. Now, as I'm writing this down, we were writing the test this morning, and we put a written or typed question. And I'm going to ask, what would you do in order to do solving this system? And you would type, well, first I would solve the second equation for y, then plug it into the first equation. Then I would solve for x. So it's real general, just you writing that makes us understand that you know what the heck is going on. So do be aware of that, giving you some extra information. Okay, so, all right, not to go over this real quick. 3x plus 2y, but since y equals this, I can substitute it, hence the name substitution. 7x plus 8 equals 1. Remember, you have your note sheets, so you're able to go ahead and follow along. I don't know why I'm talking this way. And then x equals -1. E-learning, this is fun. So go back to what you would type. So I'd solve one of the equations for y, plug it into the other equation, then solve for x. Then I would substitute that value for x in one of the two equations to solve for y. You could probably even shorten it up from there, just giving you an idea what your responsibility is. Giving you extra information I didn't have to give you. Kind of guy I am. All right, and then remember what I said. Hey, this is two lines. This solution is where they intersect. They intersect at a coordinate. So you have to write this in x comma y form when you're done. I really hope you remember this. Again, this is what 2 to 3 o'clock is for. If anything I'm covering is not clear, you're supposed to be meeting me. That is your responsibility. Boy, he's laying it on thick. All right. And then there's my favorite method. You go ahead and read all that. No time. I have to exercise what this is. Elimination. Love this method. Actually, the last question I would have done by elimination instead of substitution. Because what has to happen in that is your variables, like the x's, plus or minus, the y's, the equal sign, and the numbers must all be lined up. And they are. So the next thing is I can try to eliminate one of these variables. And I look and I see the x's and say to myself, I can multiply that by -2, and then this will become -4x, and they will become opposites, and therefore I'll add those two equations and get rid of those x's. But whatever you do to one side, say it. Anyone want to write it in the chat? Someone beat Nadia this time. Come on, Alima, you can get her this time. Whatever you do to one side. All right, Nadia won again. All right, here we go. So you distribute it, and it has to be hit through the whole equation. Ooh, sorry, that could be on YouTube. I just used first names, so students are still anonymous. I'm only projecting the screen, not the chat. All right. So I distribute the -2 to the whole equation, and then that's the whole idea of elimination, why I picked -2 to eliminate the x's. Yes, of course, you could eliminate the y's in the first step. It just was easier. I picked the easiest route. Efficiency. You know, in you being in CAT now, we're going to take stuff that you already know and try to get you to be efficient with it so that you can do it fast and then move on to more complicated stuff. All right, so we got y equals 4. -8 and a -32 is 4. Now you take that 4, and it doesn't matter which one you plug it into. You go ahead and plug it into the top one, as long as you did your math right. So maybe I could do that. Y equals 4, so I'm going to throw it in there. And then solve for x. This is 2x plus 20 equals 14. 2x subtract 20. Be good with your math. I'm not going to show this, so undo operations. -20 minus 20. 14 minus 20 is -6, and then x equals -3. And then, oh, I'm done, but I'm not. Remember, these are two lines, and they cross at the coordinate x comma y. Common mistake is to write 4 comma -3 because the order that you found them. No, coordinates are x comma y when you solve that stuff. All right. All right, moving right along. One more because this is a special case. But I'm going to go ahead and do elimination. Let me make sure I'm doing everything I'm supposed to be doing here. Abso-fruitlies. And then I'm going to look at this and say, you know what? Again, the x's really line themselves up to be eliminated if I just multiply this equation by 3. Whatever I do to one side, minus 15y, 27. All right, so -15y, 9, 18, 27. And then I'm going to go ahead and write this one just underneath it. So the x's are going to cancel. Nice. Oh, no. Something else has occurred. Oh, no. So you know what I have on the left side? A 0, a big 0. And I have a big 0 equals a number 15. There are no x's and y's anymore. I accidentally canceled both, and you're fine. This is a general rule when this happens, even when you're solving an equation. perhaps, when you lose your variables in a solving and you did valid math, but you get a false statement left over, this ain't true, 0 doesn't equal 15, then in general, that means no solution. But in the context of this question, it means the lines don't intersect. It means they're parallel. Absolutely. If I'm looking for where two lines cross and they're parallel, they never cross. So that's actually what happened in this scenario. Fine, you could just say no solution, but really in the context of this question, it means the lines are parallel. Hey, just for giggles, before I move on to the literal equations, which is the next page of notes, what if you got 0 equals 0 in a different question? So that means you lost variables, but what's left over is true. Does anyone want to put that in the chat? We'll give that a second. I'll hold the video off for a second because we're a little ahead. Nice, we got a new player. Joseph put that means they are the same line. You are correct. But it really means there's an infinite amount of shared solutions. So infinite amount of solutions because what Joseph said is they are the same line. Absolutely. And the same line has an infinite amount of solutions shared, an infinite amount of coordinates. But for solving an equation, it's the same thing. An infinite amount of x's would solve the equation as well. So, or all real numbers could be used in that place. But not in this case. You'd have to say infinite solutions, not all of the coordinates. All right. In this short thing that we're dealing with each other, I kind of have to move on from there. So, like I said, after our bell rings, I'm going to do that and do that, just in case you wanted to see some more. All right. But I'm moving on to literal equations, and we're going to do like 3 of these. Then I'll do 3 or 4 more after the bell rings and post it as a video. So you have everything you need. Hey, this is science. We really should be good at this if you've had a science class where they have your rebalance formulas. And I'm just going to go right to the example, what we need to do. So I have to solve for r in this equation. By the way, this is the classic circumference formula. So now we're going to put it in terms of r. So what that means is R became antisocial. R wants no friends by it. R wants to be by itself. I don't know what just happened there. Hey, okay, my hand hit the screen and everything went haywire. Gosh, dog, it happened again. Sorry for my language. Okay, let's try this one more time. R, oh my goodness. You know, I'm leaving this on the video so they know the trials and tribulations I go through when I'm teaching. Anyway, got a little excited there. So all you have to think about is undo operations. What is the opposite of multiply? Divide. And there you go. That's why some of these could be so easy. So what is C equal to? Or R equal to? My bad, dogs. Rough. C over 2 pi. That's it. Okay, of course they get a little bit more challenging. This is the classic Fahrenheit. When you have Celsius, how do I turn it into Fahrenheit degrees? By the way, it's like 98 degrees Fahrenheit outside. Yikes. Anyway, random information from Mr. Samuelis. Let's solve for C. That means C becomes the antisocial variable. We want C all by itself. It's very simple. How would you solve a regular equation if you wanted C by itself? Undo operations. The only difference is I can't subtract f minus 32. Well, it's all good. Just write f minus 32 then. Write it as an expression. Then really it's only one more step. Do not divide by 9/5. That's not an acceptable final answer. That looks bad, a fraction within a fraction, and I will mark you wrong for incompleteness of not putting it in the correct format. Hey, multiply by the reciprocal. A lot of times I try to teach fractions because fractions come up later in the year and a graphing calculator will not help you. A calculator with a fraction button will not help you. So you need to know how to deal with fractions. General rules of adding, general rules of multiplying, so on and so on and so forth. One thing I didn't explain, yes, this needs to have parentheses because I have to multiply the whole side of f minus 32 by 5/9. You could go ahead and distribute. I'm just going to leave it there. That's an acceptable final answer as well. Probably do these two on the after video. This one we're going to go ahead and do as our last example together. And by together, I mean you just listen. All right, e-learning, crazy stuff. Is everyone doing okay? Someone put on the chat, okay. All right, as I'm waiting for that in the chat, who's going to win that one? Nice. There's Nadia again, super fast. But okay, Jessica, all right. Doing great, Alima. Put it way out there, nice. All right, what do I do on this one? Ay caramba. Well, first thing, I have to solve for x, and it's in a fractional format. General rule when you're dealing with fractions in an equation, whatever I do to one side, do to the other, I'm going to decide to multiply by the LCD, which is just xy. This one has an x, this one has a y. The least common denominator is xy. All right? Now, how this happens, this is xy over 1. So xy gets multiplied by the 1, and then it's over that x that's already in the denominator. This is why I did this. Don't forget that xy gets multiplied over here as well. I did this because these cancel. And actually what ended up happening is I no longer have a fraction in this equation. But I have another conundrum that I have to cover real quick. This is going to be the toughest question of probably the year. I have two x's and I have to solve for one of them. So here's what you do. You subtract that x so that you can get it on the same side as the other x. Nadia, go ahead. Oh, I said our last name. I have to cut that out. I have people leaving my meeting. What's going on? Naughty, naughty. All right. So here's what I did. I subtracted the x. Now you notice they're both on the same side. So why would I do that? Then I'm going to use the glory and power of factoring. I'm going to undistribute that x now that I got on the same side. Don't leave me yet. I got 1 more second, 5 more seconds to finish this off. But I didn't want to go too fast here. I undistributed that x. X divided by x is 1 right here. So now I've turned mathematically 2 x's into 1. Divide by that y minus 1, and that ends up being the final answer. No, the y's do not cancel. So write this in a clean format. X all by itself equals y over y minus 1. No, that's a 6 over 5 equals 2 error from a previous lesson. Don't cancel those y's. So this is done. Feel free to leave now. I still see most of you on. I am going to continue and do all the ones that I have not done right now as a continuation in this movie, which is after the 18-minute point. All right, so see you guys later. All right, here we go. So I said I was going to do the rest of the examples I didn't do just as an extra, how would this work? Okay, so this is the, nope, wrong page. I'm going to do substitution method first. Okay, this says in the notes, use the substitution method. So I do have one student listening, and I'm going to give them just heads up. I'm going to go through this fast because those that saw this is just for, another example. Substitution. You take one of the equations and solve for one of the variables, any one. This one's ready to just subtract 2y. Then, hence the word substitution, I'm going to take that, substitute it into the other equation. Not x anymore, negative 2y minus 2. Plus 4y. And again, as I'm writing this down, yes, this jumps around. I've said this about this beginning thing. We're testing you on all possible algebra skills that you should remember from Math 2 and Math 3, maybe even Math 1. Write this over here for space purposes. Negative 6y minus 6, right, plus 4y equals 6. Ooh, this is going to be nice because when I add these together, this is negative 2y. And I'm going to go ahead and add 6 to both sides. Two things at once. Actually, at first I thought this was going to be 0 on the right side. Nope, we're good. Divide by negative 2. I want to make sure I didn't make a mistake there. Nope. Y equals negative 6. Then you take that and plug it back into one of the two equations. Well, the smartest thing to do is to plug it in the one that you've already solved for x for. Negative 2 y, but y is negative 6. And then this is 12 minus 2, which is 10, just for going fast. Remember, this is a line and this is a line. This is the coordinates x comma y that these two lines cross at. Okay. Alrighty. So now elimination. Now look at the y's. These aren't as easy to eliminate. I choose the easiest thing to eliminate. If I take this bottom equation and multiply it by 4, then this becomes, I'll leave this on the bottom this time, and I'll write that equation up above it. And whatever I do to one side, I do to the other. I lazily show that line that the 13 has to be hit as well. This is 12y, and then this is 40, 52. Then there's the top equation, 8x. I'll leave it on top. And then this is the elimination method. It only works if you have x's, y's, equal sign, and numbers lined up. So boom, eliminates. That's why it's called elimination. 12y and 2y is 14y. And then this is 56. Divide by 14. And then y equals, oh boy, 28, I think 4? 40 and 16, 56. Yes. Doesn't always have to be a whole number either, but it is nice that it is. And then you take this and plug it into either or. I'm going to make sure I am taping. All right, good, we are. Sometimes I forget to do my things. All right, and then I'll just choose the bottom one since I see it. Negative 2x plus 3 times 4 equals 13. Negative 2x plus 12. Oh, didn't I just say there could be a fraction? Looks like we're going to get one here. So I do have a student on here. Don't say anything, student. You know, YouTube don't want your voice on there, but I'm going to tell them the same thing I told everyone in the notes. This is going to be a test question solving a system where we're going to have you write some stuff. So what would you write on this? So I'd ask to go through a process of what we would say on this. You would write, quote, first I'd multiply the bottom equation by 4, eliminate the x's, and solve for y. Then I'd replug in that y in one of the two equations and solve for x. Period, end quote. Then you'd write the final answer. I'm going to stop the video. Okay, so literal equations, and the student that I have on, feel free to have, when I'm finished this video, go ahead and talk to me at the end of this. But this is the distance equals rate times time formula. You don't have to know that. I'm just sharing that. This one's real simple. If I'm going to solve for t, then this is just multiplication, r times. So I'm just going to divide by r. Sometimes there's that simple. So now we have this formula in terms of time. Time equals distance divided by your rate. Going over this one, this is a perimeter question for a rectangle. Hopefully you recognize that from back in the day. But what I need to do is solve for L. Now, don't get confused with this. This is really in the same format as 7 equals 2L plus 34. I don't know. This is just, don't treat it as a variable. Treat it as something where, how do I undo addition? I subtract. How do I undo times? I divide. And I do it in that order. So when I'm talking about literal equations, I like to insert numbers and make you understand that that is all you got to do. Subtract 2w. In a way, this is better though. You don't even have to calculate, because p minus 2w does not, they're not like terms. There's nothing to do other than to write it as an expression. And then 2L, I'm going to use a capital. I don't know. I don't like the lowercase l. It looks like a number. Then you're going to divide by 2. I will share two different answers for this. P minus 2w divided by 2 is fine. No, that's a 6 over 5 equals 2 error from previous notes that I yelled at you about. You can't take that 2 and cancel it with another 2 that's stuck in a binomial. So that is the final answer, Or you could separate this into two fractions and say p over 2 minus, look at that big fat minus, 2w over 2 does turn into a singular w by itself. This is equivalent to that previous answer, and hopefully that is understood. Then this last one, like I told those, this just had 2 extra steps, and then we end up somewhere around here, if you look at that one. But I'm going to solve for y now. Oh no, I get a y and a y. Don't divide both sides by y. I'll show you what happens when you do that. If you divide this side by y, then you actually make it even worse. Because no, you cannot take this y and cancel it with that. You still have 2 y's, and now you created a fraction. So you've made this a worse scenario by doing that. So hopefully you remember what I did with number 11. And what you're going to do with this one is get the y's on the same side. So subtract the y from both sides. Yes, this is a special tough one. Now that you have the y's on the same side, you can undistribute them, which is called factoring. And that's the math magic of turning 2 y's into 1. When I take a y out of this, this is x. When I take a y out of this, this is 1. And then you'll see a very similar answer to this compared to number 11, but I decided to solve for y instead of x. So that's why we get what we get here. Okay, I'm going to go ahead and stop the video. As I said and promised, I was just going to finish the notes if anyone wanted to see extra.